So it looks like that the weight of the object or the mass of the object doesn't really have an impact. It doesn't make a difference. So we could use any object here and we should be able to get the same results based on that experiment that we just did. So in other words, we could actually use a book, or hey, you know what? We could actually even use a sheet of paper and drop it and be able to get the same results and be able to calculate out our acceleration. Well, wait a minute. Maybe you're saying to yourself, I know that if I drop a book and dropping a piece of paper, that's not the same thing. The piece of paper, it's not going to fall straight down. Now, will it? What's it going to do? It's going to like do its little dance in the air and make its way to the ground, right? Well, why does it do that? And didn't we just say before the idea that the mass of the object or the weight of the object doesn't make a difference? So this, how it actually just moves in the air, why does it do this? It's because it's taking the path of least resistance. What it's having to do is cut in between the air molecules that are interfering with the path of the object. It has to cut through the air. The book, when it's going down, hey, you know what? There are air particles that is getting interference with. Not really, it's kind of insignificant when it comes to an experiment like this, so it's nothing that we actually really have to take account for when we're dealing with an experiment like this. Maybe in higher level courses, much higher level courses like graduate college courses, you'd have to think about this. And it's basically because of these air molecules that they have interference. That's if we drop this book from, let's say, 1,000 feet in the air, at a certain point, the book will stop accelerating and it will reach its terminal velocity. That's a nice little fun fact for you. It's not going to be actually worked into at all in this experiment. We will be using a book as opposed to a sheet of paper.